Hi students, in this video we are going to discuss current electricity NCERT additional exercise question number 20. Let us start the solution. This question consists of 3 parts A, B, C. First we will solve part A. N resistors of each resistance are, that means all are identical. How will you combine them to get the maximum and minimum effective resistance? Maximum possibility for series combination R and so on R. That means total n times. Then what is the effective resistance between these 2 points? Means for series combination R plus R plus R plus and so on n times. N times R, which is NR. This is the maximum possibility. Maximum possibility, why? Because these all are, we are adding directly. It's a summation of individual resistors. But whereas when it is minimum possibility, all resistors should be, all identical resistance should be placed in parallel. That is R and so on R. See here in this case what happened? N times again. N times I am placing all are in parallel. R and so on. N resistors are in parallel. Effective resistance will be equal to 1 by R plus and so on n times, which is equal to N by R. Then parallel resistance equal to R by N. This is the combination. Resistance in parallel, effective will be R by N. This is the minimum possibility. This is the maximum possibility. This is minimum possibility. Next, moving to the second part, B question. In the B question, given that the resistors 1, 2, 3, how will we combine these all 3 resistors to get the equivalent resistance? 11 by 3 ohm, 11 by 5 ohm, 6 ohm, 6 by 11 ohm. You need to check the probabilities for which combinations you are going to get 11 by 3, 11 by 5, 6 by 11. First I will take all 1, 2, 3 in series. What will happen? 1 ohm, 2 ohm, 3 ohm, all are in series. What is the effective resistance between these 2 points? In this case, R effective will be 1 plus 2 plus 3, which is 6 ohm. That is your third case. Third question in the part B. Now coming to the one more. If all are in parallel, what will happen? 1 ohm, 2 ohm, 3 ohm, all are in parallel. Effective will be, 1 by R effective will be equal to 1 by 1 plus 1 by 2 plus 1 by 3. LCM 6 plus 3 plus 2, which is 11 by 6 ohm. 1 by R effective is 11 by 6, which is R effective will be equal to 6 by 11 ohm. I think 6 by 11 is there for option 4. 11 by 6 ohm is over, 6 by 11 is over. Next you need 11 by 3, 11 by 5. I will try any 2 in series, one is parallel. Let us check. I will take 1 and 2 parallel, 1 and 2 parallel, and 3 in series. 1 and 2 parallel, that means 1 and 2 parallel is 2 into R1 R2 by, when two resistors in parallel, R1 R2 by R1 plus R2. That means 1 into 2 by 1 plus 2, which is 2 by 3. That 2 by 3 is parallel to 2 by 3 ohm is by series to 3 ohm. Then effective will be 2 by 3 plus 3. 2 by 3 plus 3, which is equal to 3 3s are 9, 11 by 3. 11 by 3 ohm. 11 by 3, it is possible. Which option? 11 by 3 is first option. Then first option is also get over. Now we need to check 11 by 5. See here, first option how it is possible. 11 by 3, 1 ohm and 2 ohm in parallel and 3 ohm in series. Two resistors 1 and 2 parallel means R1 R2 by R1 plus R2, which is 2 by 3 ohm. That 2 by 3 ohm is series with 3 ohm. Then you are going to get 11 by 3 ohm. This is one possibility, first option. Now coming to 11 by 5. How to arrange 1 ohm, 2 ohm and 3 ohm to get 11 by 5 ohm. Now check it. Now 2 and 3 I will place parallel. This is 1 ohm. This is 2 ohm. This is 3 ohm. Now these two are in parallel. 2 into 3 by 2 plus 3, which is 6 by 5. 6 by 5. This I will replace with 1 ohm and 6 by 5 ohm. This 2 and 3 parallel combination I replace with 6 by 5 ohm. Now 1 ohm and 6 by 5 ohm in series. Your answer will be 1 plus 6 by 5 ohm, which is 11 by 5 ohm. This is option 2. Students, check it once again. When you are going to get 6 ohm, all are in series, 6 ohm, all are in parallel, 6 by 11 ohm. And one more thing, 11 by 3. 11 by 3 means first two are in series, in parallel, these two are in parallel, and 3 is in series. Then you are going to get 11 by 3. Now when it is 11 by 5, your possibility 1 is in series with a combination of 2 by 3 parallel. Then your answer is 11 by 5. This is B part. Now coming to the C. In question C, they are asking, determine the equivalent resistance of the network shown in the figure. Determine the equivalent resistance of the network as shown in the figure 3.31. This is the figure 3.31. Let us see. First A question in this. 1 and 1 series, which is 2 ohm. 2 and 2 series, which is 4 ohm. Then 2 and 4 parallel, which is 2 by 4 plus 2 by 4. 2 plus 4, which is 8 by 6, which is 4 by 3 ohm. This is 4 by 3. This is also 2 and 4 parallel. This is also 4 by 3. This is 2 ohm and 4 ohm parallel, again 4 by 3. This 1 and 1, again it is 2 ohm. 2 and 2, it is 4 ohm. See here, this 2 and 4 in parallel, 4 by 3. 2 and 4 parallel, 4 by 3. 2 and 4 parallel, 4 by 3. 4 by 3. This all you can write it as 4 by 3 ohm. 4 by 3 ohm. How many times? Total 4 times. 4 by 3 ohm. And one more 4 by 3 ohm. The effective resistance will be how many times? 1, 2, 3, 4. 4 times 4 by 3. Why? Because 4 by 3 plus 4 by 3 plus 4 by 3 plus 4 by 3, which is 4 times of 4 by 3, which is 12 by 3. Sorry, 16 by 3, which is equal to 5.33. Otherwise you can leave like this. This is part A. Coming to part B. In this part B, all the resistors in between these 2 points, all are in series. 1, 2, 3, 4, 5. Maybe this diagram misled you. It is not in parallel. All are in series, end to end connections. 1, 2, 3, 4, 5. These all 5 resistors are in series. Then R equivalent is R plus R plus R plus R plus R, which is 5 times equal to 5R. This is your answer. These are the 3 parts of question.